So this is what we're going to build for this one, something like this. Let's look at the outliner. So we want to build something we can move anywhere in the scene, change its orientation, scale up the whole rig, whatever. So I've got this root node that I'll create. I'm using a curve again to control the path that this thing grows on. And then I've also got a piece of geometry that will grow. You can see I also have a little controller down here like I had before when I created the wrist controller. And I've made some extra attributes here. And I've got one called grow, which I can use to make this thing grow. So can you notice anything different about this one than the one that I did last time? Just the last example. Right. So the divisions grow, which is useful because you don't have to start with a piece of geometry that has hundreds of divisions in it all squished down. So this is a rig that does the same thing. It allows something to grow, but it allows it to adapt and have more divisions as it gets bigger. You can see there's no joint system in here. We're using a curve in a different way this time. If I change this curve shape, this will still follow it. And this is a polygon object. The other one would have worked with a polygon object too, but this one I have to use a polygon object because of the way I'm making the divisions. Okay, so let me go through constructing this. I'm just going to put this on a display layer and hide it. So we just want to start with a simple cube with no divisions beyond the basic shape. So I'm just going to create a polygon cube. Just make sure it's all set to normal. And I want to just place it so it looks like it's sitting on the ground here. So I'm just going to move it up 0.5 in Y. And then I also want to, when I scale it, I don't want it to grow out from the center and go down and go up. I want it just to grow up, right? So I have to move the pivot point down to the base. So hit home on your keyboard, function left arrow on your laptop, and just snap, grid snap it, that pivot point down to the bottom. Home to get out of that. So now if I were to scale it, it would scale up like that. So when you first create, I'm going to rename it, call it thing. When you first create something like a polycube, you have the parameters that you can change from the beginning. So there is something I could work on here, the subdivision's height. You know, I can add more divisions here, and I could work that into my rig. But we're going to do this slightly differently, and you'll see why as we go along. So actually, I can delete the history on this object. I'll freeze its transformations and delete history with my little shortcut buttons here. So what other tool do we have that we can use to add a division to this thing? Can you remember? I hear insert edge loop being whispered, and it's correct. So we can insert an edge loop which will draw a division all the way around this object. So let's do that. Go to Edit Mesh, Insert Edge Loop, and we can just click on here. And so it's created a new division. And so Insert Edge Loop is called Poly Split Ring. That's the name of the node that's created. So now we don't want to delete the history anymore because we need to keep this Poly Split Ring active because it's going to become part of the rig. So we're going to use the node editor to make some of the connections that we need here. So we've got the node editor here, and there's the thing shape. And I can just map the input and output connections with the in and out arrows up here. And so we see the poly split ring here. Connected to the object. So we have to find the shape or the transform node here, because we want to use this scale y, because remember scale y is what we're using to make it grow, right? And we want to connect the growth in y to the number of divisions that are made. Right? So let me just select this. So let's see here. It's not showing me what I need to see. Sorry, just give me 1 sec. It's just not showing me the transform node here in the node editor. Just seeing the shape node. Okay. Well, what we want to connect is if we look at the poly split ring, it's got a few settings. It's got the weight, which means the position here. Right now it's at 0.498, which means that division is almost at the halfway point. If I change it to 0.1, you can see the division goes down towards the bottom. So I can just change this to 0.5, so it's right in the middle. The split type is relative, which means the relative distance between the two surrounding edges. We can change this to multi, and so by default it's at 2, and it's created 2 divisions. And we just need that to be 1. Gives us the same sort of setting. But now we want to connect scale y to these divisions. So scale y will drive the number of divisions. Oh, there it is. Okay. So there's my thing node. So you can see that little icon there means it's the transform node. It's got this scale, translate, rotate. And I want to connect scale y to divisions here in poly split ring. So I'm going to click on the circle here. So this is the outbound connections. Here the inbound connections would come in. So I'll click on here and go to scale y. And I get this little leash that I can drag up to poly split ring and go to other, because it's not as one of the default connections. And I can connect it to divisions. So you can see the divisions now are in yellow. So if I were to grab this little guy and start scaling it up, you can see new divisions are forming. Okay. Now one thing we kind of want to avoid is that if we make this thing too small, it says it can't perform poly split ring on selection because of where I placed the initial one. It can't use the multi-selection. And this could crash your rig. So we want to do something to say never create less than one division. Always have at least one division. So we're going to start building up our network here. So you could write an expression to do that, but you can also use one of Maya's built-in nodes. If I just go into the hypershade for a second, where we see all these nodes listed, under these utility nodes, and we looked at some of these before, the sampler info and things like that, but there are other ones that control different things, like a condition node. It's a node that has a built-in if statement. If this condition is true, make this happen. If this condition is false, make this other thing happen. There's another node called a clamp node, and a clamp node sets the range on numbers that can be used. So we can use a clamp node to control how many divisions are made. So back here in the node editor, if you just hit tab, then you can call up any node that's in Maya. So if you just start typing clamp, it will find it. And so we've created a clamp node now. So what we want to do is take the value coming out of thing, which is scale y, to go into the clamp node, and that value will be coming in. And the clamp will say, take in that value, but if it's less than 0, or if it's less than 1, still make it appear as a 1. So if I go to scale y, from the transform node to the clamp node, input, and it deals with colors in this case, RGB, but same as XYZ, right? It's a triple channel. And we'll just put it in input G because it's in the same position as Y, XYZ, RGB. It doesn't really matter. And then we're going to connect the output from the clamp, output G, into poly split ring divisions. You can see that other connection disappeared because we've overwritten it. Okay, so now let's look at what the clamp node is saying. So the input here is in yellow, so that's coming in from the scale of the thing node. So it's 0.98. And we want to say the minimum value it could ever be is not 0, but instead it has to be at least 1. So that means it's always going to have at least one division. Right? And the maximum value, we can give it a high number, like 1,000, which we probably won't exceed. So the clamp node is controlling our rig, so that dumb animator can't break our model later on. So if the animator scales it down too much and it can't make the divisions, it won't break the model and the rig. We've put a safeguard in for that. Does that make sense? Okay. So that's good. So now if I select this and go down to low, you can see there's always one division in there. It's never going to go below, but if I go higher, it will start making new divisions. Okay, so that part of our rig is working. We can scale it up and it will make new divisions. So what's the next part? We need to make a curve that it can follow, right? And before we did it by making joints and then making a spline IK. And I suppose we could do that here too. Can we do that here? No, we couldn't do that here actually. The problem is that when you have a piece of geometry that you skin to a joint system, if you start adding vertices to it, then they're not skinned to anything yet. We're adding new vertices as we go along, right? So we have to do something different. And what we do instead, which works in a similar way, is use something called the wire tool. So I'll make another curve. Again, I'll just do a quick EP curve. X snap here, X snap here, and then select it and rebuild the curve. Edit curves, rebuild. So it's got, again, 8 spans maybe. So you can see we've got a lot to control, enough to control the shape. And then I'm going to delete its history, freeze its transformations. Okay, so now what the wire tool does is allows you to use a curve to deform another object. It's useful for a lot of things. So say, for example, you had a heart model and you wanted to have you wanted to model in a sort of fossa or a gully where you could put a vessel in. You could draw a curve and use that as a deformer and push it in, and it will deform that model to have a sort of deformation along the curve. So if we go to Create Deformers, Wire Tool, again it's a tool, so it's going to tell you what to do before you select anything. So it says, select an object. Nope, didn't select it properly. So it says, select shapes to deform and press enter. So we only have this one shape. So I'm going to click that, press enter. Now it says, select the wire curves and press enter to finalize the operation. So you can have more than one curve in a wire tool, but we just have one. I'm going to hit enter. And so now you can see the box turns purple, which means when I have the curve selected, which means it's historically bound to it. So when I move that wire, the box moves too, but it doesn't follow it perfectly. So let's look at the wire settings. The only thing we really have to look at here is the wire has a drop-off distance. So the wire is a deformer, and its effects are felt according to what that drop-off distance is, and it's just set to 1 right now. So we can set that to a high number, again like 1,000. So now when we move the wire, the box stays stuck right to it. The whole box is entirely enveloped within the effects of that deformer. So now when I select these CVs and move them, you can see it deforms the box. And now when I scale the box, it follows the curve. We can smooth it. So let's just look at how this wire deformer is working. And I just have a few minutes left to finish explaining this. And this afternoon, by the way, I'd like you to start working on your next shots, and I'll just be here to help out. So here's the curve that I created. I forgot to name, but when I created the wire deformer, it created this hidden object called a curve 1 base wire. And any deformer works by remembering what the thing used to be like and how you've changed it. So whenever you see a base object, it means it's what the thing was like originally. So if we make changes to the curve, Maya looks at how it's changed from the base and it deforms the object according to that. So we want to keep these things together. If we ever move them around, if we move the curve away from the base, it can cause problems. Not in this case though. So we want to group these things together. So we'll just group these and we'll call this like wire control. And then we've got our geometry. I'm going to group it with itself, and I'll just call this geo for the geometry, because you could have more than one piece of geometry that's being influenced by this, and then if you have them under a group, they stay together. Forget this root, this is from something else, the other version. And I'm going to create another controller for this, so I'll create a nerves circle. And I'll just call this control or whatever we call it, transform, because this is the thing that can be selected to move everything. And I can make these ones a children of it. I'm just going to delete its history, freeze its transformations. So I'll take the controller and the geo and make them children of the transform. So now if I select this, I can move this around. You can also group this with itself to create this higher level root node. So Command G, and I'll call this class root. So if I open this up, you've got all these separate levels of control. So if I wanted to move this around the scene, I can grab the root node, move it where it needs to be, rotate it. And because everything is a child of this root node, they all follow it. You can even scale up the whole thing if you need to change its size and shape. And then if I want to animate this, I still select, I go in here and select the thing node that I created originally, which is kind of a pain, right? So here we can make a new controller here. So let's do that again. On that circle, I'm going to create a custom attribute. So attributes, add attribute, and I'll call this one grow. This is a float again. You can start at 0, or no, let's start at 1. And the maximum can be anything, so I don't have to put anything there. I'll just put 1 here for the default. So I've got a new attribute here, and I want to connect scale y of the geometry to this. So I could do a set-driven key, or I can just use the connection editor, which is easier. So I can go to Window, General Editors, Connection Editor, and so I need so I want the circle in the right column, or sorry, the left column here. And then I want to load the geometry into the right column. So right down at the bottom, you can see that new attribute that I created, grow. And I want to connect it to the scale y of the geometry. And you can see it leapt down to that small size because grow is by default set to 1, I think. So now if I select that curve, there's grow. I'll just look at it in the channel box. So if I select the name and middle mouse drag, then I can I can control everything from there. So you create these controller objects and add these custom attributes just so they're easy to access. And if I ever want to move this around, I would probably grab the root node here. So on this transform node, I may want to only see this attribute here. So I can select all the other ones and just say hide selected. So I can just have custom display of my attributes here. So I can just do that. Okay, let me just finish up. There's one more step, and I can get done in the next 8 minutes. And this was, again, from the tutorial that I learned from online. This is, I thought, a pretty brilliant thing, because one of the things that can happen here is this is a pretty ingenious little structure to make an adaptively growing thing, but in some cases this might not work, because if you have to UV map it or something, for example, if you have new polygons and new vertices being created all the time, you can't UV map it. Or if you had to do something else to it that needed a consistent number of UVs, like a blend shape, for example, you couldn't do it with an adaptive mesh like this. So we could set up this rig to be either adaptive, as it is now, or with a set number of divisions. And here we're going to start using the condition node. Just going to clean this up a little bit. Oops, it's not very clean. Okay, so here's our thing so far. So here's the little piece of geometry with the scale in it going into the clamp, going into the poly split ring. So in the curve, that controller that we have down here, I'm going to create a couple of new nodes. Sorry, a couple of new attributes. One, I'm going to say, and again, this is not my idea, I learned it from somebody else, but auto divide. And this is a question. Do I want it to be turned to auto divide on or off? So that would be a Boolean. So a Boolean is an operation is yes or no. It's like a radio button. So this button for the Boolean is a Boolean itself. So I say OK, and so you can see I have a new attribute called auto divide. I can turn it on and I can turn it off. It doesn't do anything yet, but and then I can add a new attribute, and I'll call this one num divisions. And this one is an integer. It's not a scalar. We don't want to have 1.5. It's either 1 division or 2 divisions, right? So we'll choose an integer for this one. The minimum is going to be 1. The maximum can be anything. Default is going to be 1. Okay. Now this is where it gets confusing. So we're going to create a new node here, and I showed you before there's one called the condition node. And so what we want this to say is if that little button that says auto divide is turned on, then it should use that adaptive mesh structure. And if it's turned off, then it should use whatever number of divisions we've typed in num divisions. Okay? So let's see if I can remember how to do this. So we want to connect from that controller curve, which is here, right? So I'm going to connect from that controller curve, auto divide, into condition node, into the first term. So let's look at that condition node. So the first term is the first value you feed to it. The second term is another value. And then there's the operation. So right now it's saying, is 0 equal to 0? And the answer would be yes, right? And if it's true, then execute this. If it's false, then execute this. So color if true, color if false. So right now, auto divide is turned off, so that's why 0 is coming in here. So if auto divide is turned off, then we want the number of divisions that we've typed in to control this. So that should be color if false. Yeah. So if we go from transform, this is that circle again. And where is it? Num divisions should go into color if false. And it's a single channel, so we'll just connect it to G. Okay. And then the color if true is going to be the grow factor, right? So remember in the transform we have this grow node. Thinking or no, it should be scale from the thing, because that's being controlled by grow. So from the transform node of that thing, I'm going to go to scale y to color if true g. So you can see the condition node is here. And so now this has to ultimately go into the clamp. So I'm going to delete that connection. So the out color G will go into input G. And everything should work. I have the one that works, so I'll secretly turn this one off. So now if I select the, so auto divide is turned on right now. Oh, it's not working. So let's turn auto divide. Oh, I have it reversed, that's all. So that my color with if true should be reversed from my color if false. So right now auto divide is on. In this case it's saying listen to the number of divisions, and I can change that to whatever I want. I can still make it grow, but the number of divisions don't change. If I switch this, now auto divide is working and it's following the grow factor. Okay, let me just select this, hide it, turn on the one that actually works properly. Look, nothing happened. So auto divide is on, so when I grow it, it auto divides. When it's off, it's following what's in the divisions here. I'll change that to 20, then that changes, but when I change grow, you can see they collapse on themselves. Okay. So what I'll do is I'll post this video, and actually I wouldn't mind if you went through and just built this structure in the afternoon after lunch, just so you can get the chance to work with things like the condition node, the clamp node, working in the node editor. But this could be useful for a lot of things, anything that needs to grow tendrils of things. Now you can't make them bifurcate exactly unless you had different curves and different objects growing, but for something like angiogenesis or something, a vessel growing, this can work quite well. Any questions? Yeah.
Can you make just parts of things grow? So like if this was like, if you had a surface, can you just select a couple of faces?
Yeah, well, you could do it. I mean, you'd have to think about, so it wouldn't work with the split edge loop tool, right? Insert edge loop, because that is working more globally. But we do have the extrude face option, and that has a division setting too, right? So you could set up the same sort of thing on a face that has to extrude. Now, it wouldn't work to combine these two things because these faces are created as you go, but if you had one long thing already and selected a couple of faces and then built a rig for each one of those, then it could work. But you'd have to use extrude, the extrude command rather than the split edge loop tool. One of the other reasons that the split edge ring tool is interesting because it has some other settings you can use here, like a profile curve. So you can actually change, I have to change it back to auto divide. That's the wrong one. So the split edge ring has this profile curve thing, so you can change the shape of this thing over its length too. So there are certain benefits to using this if you want to make it kind of bulgier down at the bottom and getting skinnier. You can do that, and then it will still, should still, so you can see it changing over time, getting bulgier down at the bottom. So there's some things you can do with this that, with the extrude has a lot of other settings too. It's taper and twist, so you can probably do some interesting things with that too. So, you know, this is just one very specific example of how to do things, but I want you to look at this and think about problem solving in the future. Some of the tools you know have attributes that maybe you could affect in similar ways, like the example Green mentioned, you know, using extrude. But there might be lots of other things, and working in Maya is all about technical problem solving. So what I'd like to do for this afternoon, we'll take a break for lunch now, but I'd like you to go through this tutorial that I'll post over lunch and just try and build this thing. And then for the rest of the afternoon, I'll just be in here. if you're working on your shots, and I can help out. Okay? Great. Thank you.